You know that feeling, just drowning in information every single day. It feels like you're trying to catch up constantly.
Absolutely. It's a lot.
And you need to get a handle on complex stuff fast for work or just, to understand what's going on.
Right. You need a shortcut sometimes.
Exactly. And that's what we aim for here. Today, we're taking a deep dive into something called radio frequency identification, RFID.
Mm-hmm.
It sounds technical, maybe, but it's this really powerful, super efficient way to, well, manage and secure pretty much anything. It's quietly changing how things work all around us.
And we've got some great material to work from. This is based on a really thorough RFID tag catalog and applications from SureSolutions. It's dated June 2025, so it's pretty current.
Oh, excellent.
Yeah, it's got all the specs, sure. But what's really cool is seeing the clever engineering behind these little tags and where they actually pop up. Some surprising places.
Right. So our mission, if you will, is to sort of simplify this future of tracking, looking at these tags one by one. We'll get into the details, but also uncover some of those surprising ways they're being used out there.
Sounds good.
Okay, then, let's unpack this. This fascinating, often hidden world of RFID tags and how they're shaking up asset management. So basically, RFID gives you this powerful way to automatically keep track of things, manage them, secure them, all through the supply chain and way beyond that too.
Yeah, it's definitely a leap beyond just your standard barcode. It's automated, it's efficient, and it gives you real data to work with.
And when you look at these tags, there are a few key things that define what they can do, right?
Exactly. The fundamentals really boil down to a few core specs. You've got the operating frequency, the type of chip inside and its memory, how far away you can read it, the read range, what it's actually made of, and, its size.
Okay.
So frequency-wise, you mostly hear about UHF, ultra-high frequency. That's 860 to 960 megahertz. Great for reading things from further away. But then there's also HF, high frequency. That's 13.56 megahertz. Much shorter range, but really vital for things needing close interaction, maybe more security, or when you're dealing with metal.
And the chip, the brains of the operation.
Well, the most common standard you'll bump into is EPC Gen 2. It's popular, partly for its memory, typically 96, maybe 128 bits, for the unique ID, the electronic product code.
Okay.
But the big deal is its anti-collision capability. It means a reader can ping like hundreds of tags almost at once. Super important in a busy warehouse.
I can see that. Yeah.
Plus, they often have extra user memory. Could be just 32 bits, could be up to 4 kilobytes, good for storing extra info like batch numbers, that kind of thing.
And the HF ones?
For HF, you're looking at standards like ISO 15693 or ISO 1443. That includes things like MIFAR chips you find in, say, transit cards or payment systems.
Gotcha. And the read range you mentioned, that varies a lot.
Oh, massively. It really, really depends on the tag and the surroundings. You could be talking like 0.1 meters, super close for some HF tags.
Right.
Or you could be getting up to 10 meters with some of the big, tough UHF tags used in logistics.
Wow, 10 meters.
Yeah. What's fascinating here is how these basic specs are tweaked and engineered so precisely to solve very specific problems in all sorts of different industries.
It's amazing. And the materials, too. You said it's not just plastic labels.
Not at all. I mean, you've got your thin PET or paper ones, sure, but also rigid plastics, woven fabrics, special glass mounts, even engineered foams and polymers. And the sizes are all over the place. Tiny little 15-millimeter circles for, like, jewelry, all the way up to these big 100 by 50 by 10 millimeter rugged blocks designed to be bolted onto pallets.
Okay, let's start with the ones you might see, or rather not see, every day. The sort of workhorse tags, the cheap ones.
Yeah, the cost-effective ones like the thin petit or paper backing tags, super common, maybe 70 by 25 millimeters. And yeah, really inexpensive, around $4.50 or so.
Then where do you find those mainly?
Their strength is volume. So supply chains love them. On packaging, tracking pallets and cartons in warehouses, on box goods in retail for inventory, that kind of thing.
Okay.
They typically have a read range of about 4 to 7 meters, which is pretty good for quickly scanning a whole area.
Makes sense. Then you mentioned printable paper face tags. Slightly more, about 5.50.
Right. Self-adhesive, standard size, like 50 by 30 millimeter. The cool thing is they can be printed on easily, integrated into existing label printing.
Ah, convenient.
Yeah, perfect for apparel inventory. They can be part of the price tag you barely notice. But also useful for, say, tracking documents or file folders in big offices. Automates that whole process.
Okay. And hang tags. Like on clothes.
Yeah.
About 6.0.
Exactly. The ones with the string or the little plastic. Yeah. You hold up a shirt, the mirror reads the tag, and instantly tells you if they have other sizes or colors in stock. It's not just inventory anymore. It's like enhancing the customer experience right there.
That is an aha moment.
Yeah.
Takes it beyond just tracking boxes.
Definitely. Okay, so now let's shift gears. Let's talk about tags built for tougher spots, really specific needs. Jewelry tags, for instance.
Tiny ones, right.
Yeah, really small, 15, 20 millimeter diameter maybe. They have a protective layer, and crucially, they're designed to work on or near metal, which is tricky for RFID.
How do they manage that?
Sometimes they even use dual-frequency UHF or HF. HF is naturally better near metal, but UHF gives more range if they can engineer it right. It's about getting accuracy on those high-value items.
So applications are pretty clear then. Security.
Absolutely. High-value jewelry security, tying into anti-theft gates, making stock audits way faster and more accurate, even automating checkout in luxury stores, authenticating the item.
And the read range is different for HF versus UHF on metal.
Big difference. UHF on metal, you might get 1 to 2 meters, useful for gates. HF is much closer, like 10 to 30 centimeters, for that pinpoint accuracy when scanning individual pieces.
Okay, now this next one sounds wild. Laundry tags. 35.0.
Ah! Yeah, these are pretty remarkable. They're encased in this special heat-stable polymer. They can handle temps up to 100 degrees C, totally waterproof, survive harsh detergents.
Wow.
And even direct ironing up to 180 degrees C, usually smallish, like 50 by 10 millimeters, and you sew them or weld them right into the fabric.
Here's where it gets really interesting. A tag that can survive the laundry. I mean, industrial laundry.
Exactly. Think about commercial laundries, tracking linens for hotels, hospitals, managing uniforms, knowing how many wash cycles something's been through, even tracking industrial workwear. It totally changes asset management for textiles.
Incredible durability. Okay, what about dealing with metal interference more generally? You mentioned foam back tags, also around 35.0.
Right. So metal usually messes with UHF signals. These tags may be 60 by 60 millimeters square, have the RFID inlays sandwiched between two soft foam layers, usually ethylene foam, with a rigid bit in the middle.
And the foam helps how?
It creates space. That foam acts as a spacer, lifting the tag slightly off the metal surface. That air gap is crucial to reduce interference and let the tag be read reliably, maybe 2 to 4 meters range.
Clever. So these are for
Tracking metal stuff. Tools, equipment in factories, tagging pipes, valves in industrial settings, logistics tracking metal drums, containers, anywhere you need to stick a tag on bare metal.
Makes sense. And tire tags, 40.0. They sound specialized.
Very. They're encased in this flexible but tough heat-resistant polyurethane. The key is they have to flex the tire as it moves without breaking.
Oh, okay.
Usually adhesive or clamp-mounted, maybe 50 by 30 by 5 millimeters.
And then the use cases.
Obvious one is tire inventory in car plants.
Yep.
But also fleet maintenance tracking mileage when tires were swapped. And even motorsport think pit lanes, quickly identifying which set of tires is which. Super fast scanning.
Okay, moving into some of the higher value or more integrated solutions, woven fabric tags. These are only 7.0, surprisingly.
Yeah, they're interesting. It's actually woven taffeta fabric, and the antenna and chip are embedded right in there. Edges are reinforced, and they're heat-sealed or stitched in, usually pretty small, like 50 by 15 millimeter.
So very discreet.
Exactly. Ideal for putting inside the collars of premium clothes. Also used in textile manufacturing itself, maybe for tracking defects or managing rolls of fabric. And a big one. Fashion brand authentication. Helps fight counterfeits.
Right, protecting the brand. Okay, cards again. Windshield tags, 35.00.
Yep. These have a special acrylic housing designed to mount on glass inside the windshield, UV-resistant adhesive backing, and often dual frequency, HF and UHF.
Why dual frequency?
Gives you options. Reliable short-range reads, maybe for secure access, plus longer range for things like automated tolling.
Ah, like the ETC tags.
Exactly. Automated toll collection, also vehicle access control, gated communities, company parking lots, parking management systems. Read range is typically about half a meter to a meter, read from outside the car.
Got it. Now for heavy-duty stuff, rugged pallet tags. These are pricier, 45.00.
They need to be tough, housed in really durable polyethylene or ABS plastic, built to survive getting knocked by forklifts, being stacked high, the general abuse of a warehouse. They're bigger too, maybe 100 by 50 by 10 millimeters.
And the payoff is range.
Big time. An impressive 6 to 10 meter read range, Perfect for scanning whole pallets moving in or out of a warehouse. Great for cross-docking, scan stuff quickly without needing direct line of sight. Even used in cold chain logistics for tracking temperature-sensitive pallets.
That range makes a huge difference in those environments.
Definitely cuts down manual work, improves accuracy massively.
We also have hard ABS rigid acrylic tags. 38.0. Sounds similar, but maybe less extreme.
Yeah, still very durable. Rigid acrylic shell, encapsulated inlay, often have mounting holes so you can screw or bolt them onto things, maybe 70 by 30 by 3 millimeter.
And these are good for
Returnable items. Things like reusable plastic bins, containers that go back and forth. Also big in automotive manufacturing for tracking parts in the assembly line. And durable enough for libraries, media tagging, stuff that gets handled a lot.
Okay, and then the top end, price-wise. PCB-based tags at 80.000. What makes them special?
PCB means printed circuit board. So the tag itself is built on a small circuit board that makes them very resistant to heat and chemicals. Plus, you can often solder them or fix them really securely onto metal surfaces.
Direct metal attachment.
Yeah, they perform really well on metal because of the design. Sizes vary, maybe 30 to 60 millimeters, and you can get really good read range, up to 6 or 8 meters even on metal.
So where do you absolutely need that kind of performance and resilience?
Heavy industrial asset management, tracking critical IT assets like servers and data centers, and again, vehicle parts tracking in tough manufacturing environments. This really raises an important question, doesn't it, about how sophisticated engineering enables this kind of precision tracking, even when the environment is really working against you.
Absolutely. Okay, let's shift focus slightly. Tags more for people and access, like PVC card tags. Yeah. 25.00, standard card size.
Exactly. Your typical credit card size, 85.6 by 54 millimeters. You can get them with HF or UHF chips. Depends what you need them for.
Which determines the use case, right?
Pretty much.
Right.
Think employee badges for building access. That's often HF for close proximity tapping. Library cards, membership cards, transit passes. If you need longer range, like maybe for vehicle access using the same card, you might use UHF.
And the range difference is significant.
Oh, yeah. HF is very close, like 0.1 to 0.15 meters. Tap and go. UHF could be 3 to 5 meters, much further.
Right. What about wristband tags, 35.00?
These are usually soft adjustable bands, TPU or silicone, waterproof. Often designed to be tamper-evident, so you know if someone's taken it off. About 250 millimeters long, usually.
I see these at events all the time.
Yep. Event management is huge. Entry control, cashless payments, tracking where attendees go. Amusement parks use them for ride access, lockers.
Any surprising uses here?
I think a hospital patient ID is a really important one, linking the wristband directly to the patient's electronic chart. Big implications for safety and efficiency.
Definitely. Okay, then compact hard tags. 30.000.
These are small, rugged little things. Plastic or ABS casing. Waterproof, dustproof, can handle a few knocks, usually around 30 to 50 millimeters.
And their niche?
Durability in a small package. Great for tool tracking like power tools and workshop. Retail asset protection, attaching them to high-value goods. And tracking healthcare equipment that moves around a hospital.
Got it. And lastly, this combo tag idea. RFID plus EAS. That sounds clever. 17.000.
It is pretty neat. EAS is the anti-theft tech, the gates that beep at store exits, usually acoustomagnetic or RF. These tags combine an RFID chip for all the inventory data with an EAS component for security.
So one tag does both jobs.
Exactly. Lightweight, flexible, often integrated right into packaging or labels, maybe 45 to 60 millimeters long.
Where would you use these?
Retail clothing stores are a big one-track inventory with RFID, prevent theft with EAS. Libraries, same idea. And pharmaceuticals track packages for authenticity and supply chain visibility, plus add